the purpose of this workshop is going to introduce you to the process of data cleaning from raw data to the final network object. Because when you work with social network analysis tools, those tools require you to use a specific format, require that your data is in a very specific format. So I'm going to walk you through the steps for going from this raw data to these objects that are network objects and are susceptible to be analyzed by social network analysis tools. The idea of the workshop is to introduce you to the process and give you the tools so that you can take the framework to your house, to your home, and do it on your own data. And so I want you to have like a big picture mind in this workshop. Really try to understand the process more than this specific function works like this, or this specific function can be tailored in this way. So don't focus so much on that. Try to understand more the process, the idea, the general steps, and the general tools that you can use. So how is this going to work? I'm going to start in a very conceptual way, like giving you the concepts of each step, each phase in the process, how this is going to work. And then we're going to walk through an example to do how these phases, how these processes work in a real data. It's a synthetic data that I created, but mimics all the characteristics of raw data that you would get. And so how are we going to do this? In the Dropbox folder, you will have this file, the one that ends in .r. So this is the file that you should have in your computers. So you can download it and also download data that we will be using for the example. And these are the files that you will be using. I'm going to be using is an exact copy of the code that you will have. So here's the code. Here's the code, like right here. And the file that I'll be using is an exact copy of that code, but just in a format that is going to make it easier for you to see. So while you are in the code, I'm going to be having this screen here that is exactly the same of the code, but you can see that it's bigger and is more friendly to see what I'm doing. I'm going to be showing you. So that's how we are going to work. All right. OK, so can you raise your hand if you have already downloaded the script and already have it running in your computer? OK, maybe we need. OK. Ready? Can we show of hands again? If you are ready. OK. All right. Yeah. OK, so while we're working on only those specific cases, we can already start trying to understand the process, the conceptual part of the workshop. So what is data cleaning when it comes to social network analysis? As I was saying, in social network analysis, we have specific tools in R. We have iGraph and StatNet are the most popular suites of packages that we use. And those packages need a very specific format. In this workshop, and this is only a note for you, I'm going to skip some things because of the time. But if you will be able to run the script, the whole script in your house and see, like, because in all the script, I have many tips and many little tips in many parts and describe like the functions very well. So here you will see that I will skip a little bit the things that are not so important, but I definitely I will definitely give you an idea of the whole process that is the most important thing that you should get out of the workshop. So these two tools, iGraph and StatNet, they are not compatible. You cannot work with both of them at the same time. So if you want to work, if you want to analyze a network, you have to use one or the other, or do it sequentially. So you have to unload one so that you can load the other, because they are incompatible. So in this workshop, I'm going to be using a StatNet. You also want to be mindful, usually people recommend, load the libraries at the beginning of the workshop, at the beginning of your code. I'm not going to be doing that, and I recommend that you do not load StatNet until you are really going to construct your network and analyze your data, because StatNet is also can mess up with the functions that are already part of R. So you don't want to have those conflicts. You want to load it once you have your data clean. Yeah. So StatNet, usually for network analysis, and especially if you are collecting your own data, you are going to be creating your network object from scratch, from raw data. And StatNet can do that, but only if you have your data in 4 specific formats, in one of 4 specific formats. So you can have an adjacency matrix, and you can run the code you have in your computer. And also, this is just a quick side. Like for running code, you don't need like to highlight the whole line and then Control or Command if you're in Mac, Enter. You can just only place your cursor in whatever place of the line that you want to run, and then Command Enter or Control Enter. Like you don't need to be highlighting everything. Just a quick note that is useful. But if you want to do, for instance, only this part, only run this part, then it's useful that you highlight and then Control Enter or Command Enter if you are in Mac. Okay. Okay, so this is the adjacency matrix. This is one of the 4 formats that StatNet will use. As you can see here, this is the format. So what you should be thinking right now is my data, the raw data that I have, has to be somehow turned into this, into one of these. So it can be an adjacency matrix, or here we have in an edge list format. So an edge list format, you see, I have one column for the ID, another column for the 2 ID, and then the weight of the relationship. And so what you have to understand is this is the final product that we have to get after cleaning the data. Then we also have an incidence matrix that is these column names are the names of the relationship. So meaning Jim having 1 in the H1 is Jim tied to Molly. So if there is a link between Jim and Molly, Jim will have like a 1 in the tie between Jim and Molly. Does that make sense? This is not very commonly used. The most common format is the edge list, but I still want to give you an idea of all of the possibilities that you have, because sometimes, especially if your data is small, sometimes it might be easier to construct a matrix. And so it's rarely, but sometimes. So I want to give you the option. Also, you can have like a bipartite network if you have people, but also other entities, like the 2 different entities of nodes. So Jim is laughing because he sees himself in the chorus. Yeah. and like you can see that you have nodes that are people, but also people belonging to baseball clubs, to different bigger organizations. So this is another format that the StatNet can work with. Plus, you always will need your list of nodes with attributes. So you will have like person 1, and this is female, this race, these characteristics, the characteristics of interest that you want. So you have to, what you have to have for the network objects to work is a combination of one of these formats that I just showed you, plus the list of the nodes with attributes. So that's what we are going to create by the end of this workshop, okay? But we can create this in a very systematic way, following some very systematic steps so that you are never lost. Because sometimes in R, the most common trouble is that people get paralyzed. We don't know what to do. We don't know. It's like, what now? Now what do we do? And so if you have the steps of the process very clear in your mind, if you understand, okay, here I have to do this, then I have to do this, then I have to do this reduces the uncertainty. And you are not going to be paralyzed or frozen, but you know exactly what you need to be doing and how you are going to get unstuck if you ever get stuck. Yeah? So the process is a very simple process. Big picture, we have 4 phases. The first phase, we inspect and evaluate our data. So you want to look at what we have, we want to use functions that let us look at what we have and identify the useful things that we have. Then we have to make a plan. And so now that we know what we have to make a plan to transform what we have into one of the formats that I just showed you. So we have to go into one of those formats that the social network analysis tools will understand. Then we have to construct, in this case, this process is applicable to many other types of data cleaning. But in this specific case, the goal is to construct a network object because we are working with social network analysis tools. So then the third phase will be to implement our plan. That in this case is construct our network object. And then the fourth step, the fourth phase, is to check our work. And you really want to do this because you want to check that your network, the network that you created, it has certain properties and it really shows the characteristics of your raw data. And so I'll show you specific things that you have to do in each phase so that the process, again, is more like systematic and not uncertain. So in the first phase, we have a very clear goal. And the goal is to identify what we need to do with the data. And so what we need to identify is really two things. The useful bits for network objects. So we have to identify in the data what pieces of the data are going to be our nodes. What pieces of the data represent the relationships. What pieces of the data are going to be the edge attributes, like for instance, if I have the weight or if I have different types of relationships. So those are the things that you have to look in your data. Then you have to identify the issues that you have to deal with. And those issues are come in two types. The first type of issues is at the observation level. So you might have missing values, extreme values, nonsensical values, things like you have somebody with a negative age. Or extreme values in the case of networks is if somebody told you that he has a relationship with everyone in the roster. You know, like if somebody, those kinds of extreme cases you can find, and it's very useful that you know that you can find them so that you can find later, okay, is this really an extreme value? Is this person friends with everybody? Or was this person trying to be funny? You know, like all of those things you want to know. And then, so the second kinds of issues that you want to identify is at the structure level. So at the structure level, do we have unnecessary columns? Columns where we don't need to have them. It's just cluttering our space. Preview rows, and this is very important because I know many of you are planning to collect data. In Qualtrics, another software that is for survey, for data collection, sometimes the first rows are not really rows, are not really observations, but they appear in your data set because it was you testing, trying to make like the pilot test, and they appear in your data set. So you want to be very mindful of that kind of thing. And also you want to be mindful of things that are in the wrong format, that columns that should be rows, rows that should be columns, columns that should be combined, that kind of a structural thing. But you can see that if you go in a very systematic way and you go, okay, let's identify this first, and let's identify this second, and let's go through this, is a very easy process. You're not going to be lost. The tip here is not to start manipulating your data because sometimes you find, okay, I found missing values, and you want to deal with that right at the moment. And my tip for you is not to do that. Wait until you have a good sense, a good understanding of your data, and then start manipulating. Because sometimes you manipulate the data, and like you do some transformation or remove some values, and actually those values were related to another problem that you find later. So it's better to first have a very good understanding of what you have, and then start doing all of the cleaning stuff. So now we have looked at our data. We identified the very useful bits. Now we have to make a plan. With what we have to come up with a task or a series of tasks to solve each issue. And this part is very important. It's very, very important because this is what people in statistics, computer science call a pseudocode. That is like your series of tasks that you have identified in an explicit way. Especially when you are beginning to work with R, this is very important because it will clarify later on what you need to do. But if you don't have an idea of what you need to do, it's going to be impossible for you to find the right functions and find the right tools to do that. Okay? So first, and this mirrors the organization that I had before, you have to plan changes at the observation level. That is like missing values, extreme values. So what are you going to do with that? And that is going to depend a lot on what is the source of the problem. Like this person trying to be funny or this person really being friends with everybody. Then you have to plan the tasks that you need to do for restructuring your data set. So the first thing that we have to do is choose the type of input structure for the network package. So you want to know, okay, am I going to construct an edge list, adjacency matrix, incidence matrix? What kind of object is the goal? Is going to be my goal. Usually edge list to make it sure, but there are also these other options. And then describe the series of tasks. So it's going to be like your roadmap. Like what am I going to do to get from my raw data to the network object. After this phase, we are going to implement the plan. And we implement the plan by finding functions that do one or more of the tasks that we had in our pseudocode, in our plan. But this is it's very key that we have identified the type of object that we need to manipulate and which task we want to do with it. So for instance, if I say, okay, as part of my plan, I'm going to combine column A with column B, then you know, okay, the object here is columns, the task combining. And so having identified this is very easy for me to even Google it, like, okay, how can I combine columns in R? And it's gonna give you all the tools that you need. If you know these two things, like the object and the task, you can find later in a million tools. Because sometimes what happens with R is that you have lots of information and manual packages and like lots of information, but you don't know where to find that or how to find what is useful for you. But if you have identified these two pieces of information, it's going to be easier. Also because there are packages that are made for very specific types of objects or for very specific types of tasks. So for instance, string R for strings, for things like words, characters, tidyr for manipulating rows and columns. And so if you know, okay, I want to combine these two columns, I want to manipulate these two columns, you go for the specific package that specializes in dealing with rows and columns. So the uncertainty is not there anymore. You know what you need to do. So once you know what you need to do, where can you find the suitable functions for your tasks? The first place where I look for these things is the cheat sheets. These things are the best thing. Yeah, really. So I put the useful cheat sheets, the most useful cheat sheets for going for working with raw data that is going to be turned into social network analysis already in the Dropbox. So you can find that. But here I'm going to show you an example of this. So here, I don't know if you can see a lot. But here's an example of one of these. And these cheat sheets come with all of the possible functions of a certain package of many useful functions, and they come with visuals. So you know here, you know exactly what is going to happen to your data. You know exactly what you are doing, and so it's also very easy to find lots and lots of different functions because you have them all here. And so it's a very useful tool to have a very clear idea, not just of the function that you have, but also very informative for future tasks. It can inspire you. It can give you lots of information of different things that you could do, and also quickly find, okay, if it's not this, if it's not filtered the function that I want, can I use this one, or can I use this one, or it's quickly you can find a solution to your problems. And also other bits of information that can complement whatever function you will need. Okay. Okay. Also, it's very good to work with this because they build a lot of familiarity with the package, and so you get accustomed and you understand how the package works, and then you get all of these tools with you. Another useful thing, if you already know which package you will be working with, is to use the vignettes. And here I show you, vignettes are easier to understand than a manual. And have less information than a manual or package manual, but they are less intuitive than a cheat sheet. But still, they have useful information, so I put it there. And another way to do it is to look for the manual of the packages. So for instance, this is the manual of the package that we will be using today. And you see that they have a list of all the functions that they have. So you can browse here, and look for something that will be useful for you. And another tool is just simply Googling it. But for it, you have to be very sure of, you have to have identified the object and the task that you want to do. And look, like, it's very easy. Like, you just, even sometimes, like, how to combine. It already shows me, many people look for this. So it already shows me that many people have looked for this, and it's easy to find some suitable function if I already know which type of objects I'm gonna manipulate. Yeah? And the fourth final phase is check your work. So once we have implemented our plan, done the things that we wanted to do, we have to make sure that everything makes sense, that everything fits. And so we want to look at basic descriptives, we want to make plots, we want to do different things that would allow you to check whether it makes sense or not what you did. So now we're going to go through each phase in a little bit more detail by working with an example. So this example is a nomination network. Is an example that I created. This is called a synthetic data set because I wanted it to have like certain characteristics, and I basically dirtied it so that we can now like clean it. The first thing we will need to do is install this package, the OpenXLX. And the way to do it is you have it in your code, not commented. Like commented means that it has a pound sign. But for you to read it, you need to uncomment it. So, where am I? Okay. So let's say here I am in your code. So I just have to, like erase the pound and install the package. Okay, so please install the package and load the library, like all of the libraries that I have there in the code. And then the next thing we will need to do is set your working directory, which I imagine like yesterday, whichever folder you created for putting the files from yesterday. Put the file that is in the Dropbox, this file, the XLSX file, because this is the file that we will be working on. So if you set your working directory and you run this command list.files, it will tell you the files that you have in your working directory, and that is going to make it very easy for you to select the file that you want to read and make it read.
Just a reminder for you poor PC users out there, // problem. So when you're cutting and pasting directory path on properties, you're going to have to switch the direction if you don't already have it in your hardcode earlier. Just to help forestall some frustration.
Yeah, and if you could please show your hand if you have already read your data set, got into this point. Okay, okay. And now can you show hands if you haven't been able yet to load your data set? Okay, let's give a couple, 1 minute for you to get it, because I really want you to have the data set with you. So you will have two data sets. The first data set, this data set, is the raw data that you get from Qualtrics, from whatever survey tool that you have, is your raw data, the survey. And this P-code file is the person codebook, where you have, like, because people have been identified with a code so that you don't have to have the names there, usually this will happen. Like, people will give you a code code for the people. So you will have people and then a number, an ID number that they assign to them. So we have these two data sets. And now we can move on to inspect our data. This is the first phase of the process. So the first step will be to understand the structure of the data. And here in the code, you will see some very useful functions to understand the structure of your data. The first thing that you will do is run this command class, that it will tell you which type of object your data is. Usually, it's going to be a data frame or a table. That's the most common type of object that you will have. But still, you might want to check, because sometimes people use other types of data, and it's very important that you do that. The next thing that you can do is, if you run the line names data met, you will be able to look at the columns, and the names of the columns in your data set. And here you can already see that there are many columns that don't make sense. It's not very informative. I have no idea what Q37, Q.5 means. So it's the first thing that you see. And here you can put, like, I have put like red flags. Some of the column names are not very informative. So I do each of these tags for both my data set and the person code to make sure that I understand what I have in both data sets. So we look at the survey, and I found out, like, what really these columns mean. Okay, what these columns mean. And so this is what you would have to do. You would have to go to your survey or a codebook or some source to figure out what your columns mean. Then the next thing that we will do is use this function str that stands for structure. And this is a very useful function because it tells you, first of all, how many observations you have, how many variables you have, and also the names of the variables, which type they are, and as many observations as R can fit in the console. So this is very useful to have a very quick understanding of what you have. And here you have that. Here you see that you have a lot of things that don't make a lot of sense. It's not something that is very useful. All of these, start date, end date, status, progress, duration in seconds, is things that usually will come in your raw data, especially if you use Qualtrics or a survey tool. This will come. And you also see, like, that you have names. This is also very useful. And this is the thing that I was telling you about, the distribution channel column that comes with preview, email, preview, preview. This is the one that you have to be very careful when you work with survey tools, because these are the ones that you were testing, and the survey tool thought that were real observations. So you want to get rid of them later. Okay, and then you see lots of NAs. You see also useful things like, okay, this seems to be something about some characteristic of the person. This also seems to be some characteristic, whether they are in a hospital, maybe. But we will see. So it's a first look at the data. You can do the same. Some people like this more, that is glimpse. This function is basically the same. So I'm not going to get into that, but sometimes people like it more. Then the next thing that you can do is run this line of command head, and this will let you look at the first rows of the first six observations of your data. And so here you have a better understanding of what you have inside. Say you have the names. You now know it's medicine and nursing, so this is probably the area of the person, and because you work with your code book, you can see, okay, This is what I have here, this is what I have there in this other part of the data set. Okay, what would be, maybe I can use this for attributes. This FF is gender, I can also use that for attributes. You know, like you can see all of those things. You can also use this line of command, the tail command, if you keep going, and that's going to show you the last rows of your data. And that is very useful too, because in that way you can see how, whether your data is structured in a certain way, is sorted in a certain way. Sometimes like people are organized alphabetically or not, and that could be useful for some things, and you can see a little bit more of this data. Another very useful function that you can use is the summary function. The summary function, and please run it, the summary function is going to tell you the distribution of each numeric variable. Why this is so useful? This is so useful because here is where you can find your extreme values. Here is where you can find it also gives you the number of NAs in your data. NA is the way that R calls the missing values. So all the missing values are called as NA. So you will see here the NAs are the number of missing values that you have in Q1, for example. And here is something very interesting. So looking down, I didn't discuss in a lot of detail, but in your code you will have. We saw that we had 227 people, 227 nodes. But somehow, and this Q1 through Q10 are the nomination questions. So these are the questions where people nominated somebody that they are friends with or that they discuss medicine matters with. I think that was the question. So in each of these Q1, Q2, Q3, if we look at it, if we go to the head, we see that in each of them we have the code of the people who were nominated. So we see that the round number 213 is friends or discuss medicine matters with person 218 and also with person 190. And so these questions, Q1 up to Q10, are these nomination questions. And that's very important to understand because now we know that from Q1 to Q10 is the data that we will use for our network, for our edges. And it's very important. So you see here is actually 200, because this is the tail, because these are the last observations in our data set, we know that we have 217 people max. And when we see this summary function, we see in this Q1 that we have actually a number 609. So this is impossible. This was an error. This was something went wrong there. And so this is with this summary function, you can go variable by variable in the variables that are of your interest, finding all of those weird things like negative values, things like weird things that can appear. So for each, it gives you a summary for each variable. This is not so useful, you see, for the character variables. It's not so useful because it doesn't tell you anything, but particularly for the things that are numeric, it will give you a very good understanding of what you have. All right. So what we can do for those things that are characters, for those things that are not numeric, we can do these tables. And so if you go a little bit down the code, you can run the commands that are simple tables, and it will tell you how many people are in each category. And so we see that we have in the distribution channel, that was our first issue, we see that we have 212 people that got the right distribution channel and 5 people that were preview, that were you testing the survey. You can also add this very cool thing that is use NA, if any, at the end of your table function, and it will include the number of NAs that you have or missing values that you have in per each variable. And so you want to do this process of getting a table of all of your variables for all your variables that are important to you, that you think somehow will be useful for your network. And this is very important because, first of all, look at this. It can also give you, sometimes people don't code, recode in the data set, or Qualtrics does that, to unknown instead of missing value. So this is very important, that you find categories that are not very good. And also, for example, you can look at this to see if some of the attributes are really useful, distinguishing attributes or not. For example, we have this variable that tells you to which hospital the person belongs. And you see that only 3 people belong to this city hospital and everybody else to the regional hospital. So it's not a distinguishing feature, so you probably shouldn't use it as an attribute. Yeah? So all of this is the most important step. I won't go into detail, but you go through this, you go through this process of looking at each and every variable and finding each and every thing that you can. Then you make a plan. Then you say, okay, with the data that I have, what do I need to do? I'm going to remove the preview observations, for example. And you do that with each of the levels. So at the observation level, I'm going to do this. And now, for the structure level, we need, as we had discussed before, we need 3 things. We need actually 2 things. We need the node list, so the nodes with the attributes, and also an edge list. So we are going to construct the edge list. And here, I'm not going to get into detail, but when you run this code at home, you will see how I'm saying, okay, here, my first step, I'm going to create a data frame. And then in that new data frame, I'm going to store only the ID, the gender, and the area and age that are going to be my attributes. And I'm not going to store anything else. And then I'm also going to rename them because they have weird names. And this is what you have to do, like have a plan of what you want to do. The node list is easier, the edge list is more difficult, but I think if you can run this at home, you will get the idea of what I'm doing there. Then we create the network object, and then we add the attributes. And you will see this when you run. But for now, up to here, I have my plan. And then I implement the plan. I implement the plan, and I show you in this phase several functions that you can use to implement your plan. But the thing is that the specific tasks that you will do are very tied to the specific data that you have. So no matter, I cannot give you an extensive list of the tasks, because the task that you will do is very, very specific to your plan. But what I could show you is where to find the function that is going to be helpful for you through the cheat sheets, through the manuals, through Google, through all these different things. But here still, I'm showing you exactly what I wanted to do for the list, for example. Here, or for removing values. So here, I'm doing for every task using a function that is suitable for each of the steps that I had in my plan, in my pseudocode. Very important, this is for every little task that you do is a reproduction at a small scale of the general process of looking, making a plan, doing, looking again. So here, first you look. Second, you do your task. And third, you look again to see if it worked. See? So here, you look to see whether the previews are gone. And here you see that now everything is email, no more previews. So you want to always go through that process. Look, implement, look, plan, implement, and look again to see if it worked. I'm not going to go through all of this because it's something that you can go at home a little bit. But I'm going to tell you that after doing the process of, okay, finding a suitable function for each of the tasks that I wanted to do, I finished with the edge list. So for instance, I finished with the edge list. That is this. This is the final product. After doing all of the tasks, and I walk you through the code, so when you do this at home, you will see. But this is what I finished with. I have the sender, that is the number of the first node, and the target. And I have a list of all the possible ages, And I go through this cleaning process step by step by having first a plan and then implementing my code. So now I'm ready to create the network object. So I can load the statnet package. As you can see, it's a lot. And then what I do, and this is something that you should know is very important, is the first thing you want to know is you want to do with network packages is initialize a network. And what this function initialize does is it creates an empty network. And you always want to do this because when you tell R, I want you to create a network that has this many number of nodes, that is the number of nodes total that you have, it will create that and it will allow you to have isolates. Because if you only use the edge list, it's only going to create the number, as many people as have contacts, but not people who are isolated. So you always want to create first an empty network that is of the size of all of your nodes, whether or not they have relationships or not. Then this is the function network edge list, or there are other options. If you look at the network package, you can also do it from the things that I show you, from an adjacency matrix, from different things. Yeah.
So I think some people might be having trouble with the read XLSX function. Is anyone else having that issue with how they add it? With getting the file ready to begin with? Sorry, nobody has. So if you are having that issue, you want to type install.packages, open XLSX, which was commented out in the program.
Yeah.
And then read in the library.
Yeah.
Sorry. Anyway.
Okay, so this network edge list is a function that will allow you to create the network. So here I'm basically creating the network with these functions, and I'm adding vertices. So I'm adding vertices from the node list that I had created, where I had the nodes and each attribute for every node. And here, because of time, again, like you can run this at home. But I want to go through the steps through which you want to check your work once you have the network. So the first quick check is only to put the name of your network and like Command Enter or Control Enter, just run that, and it will tell you already like the general attributes of your network. So what you want to look for is how many vertices does it have, and does the number of vertices that it tells you it has match with the number of people you had in your survey, with the number of people you had. Do you have the attribute, which attributes you have? Age, area, gender, vertex names. Those are the attributes that you wanted to add. Are those correctly added? So you want to check whether these attributes match with the attributes that you wanted it to have. You also want to, if you do summary.network, it will give you the option to also look at the characteristics of the attributes, at the distributions of the attributes. So here you can see, for example, this is the distribution of age. And you can look in your data, in your raw data, whether this matches with the distribution of this attribute that you had in your raw data to see if you transfer everything well. You see the number of males and females, etc. This I'm going to go fast because it's only the list of edges that summary that the network will give you. Just to show you the final test. And so the final test that you do is you plot your network. And you want to plot to see if you had isolates. Because we had seen in our raw data and through the process that we had before that we should have isolates. But many times when you work with edge lists, if you don't do it correctly, you will see that even though you have isolates in your data, those isolates are not showing in your plot. So that's a big red flag that something went wrong. So you want to make sure that you see the isolates. And also, in general, like sometimes you have an intuition of how connected should these people be. So for instance, we saw that we had 830 ties. Does this look like something that makes sense? Sometimes you have very sparse networks and you have like many, many nodes, but very little ties. The relationship is in that way. And so here you should see that. You should see that it corresponds, that you have not very many ties and lots of nodes, if that is the case. So you can look at the plot and look if it makes sense given the data that you gave it. Okay, so that is the process of cleaning your data and going from the raw data to a network data to a network object in general. And now I'm going to give you some tips for when things don't work. And this is very important because it's common to get stuck on R. Sometimes it just doesn't work, and sometimes you try to run the functions, but the documentation is not very good sometimes, and so you don't apply the arguments very well, and then you get errors and you don't know what to do. And so if you get an error of some kind somewhere, the first thing is to try to understand what the error is telling you, what the message is, and look for clues in it. Maybe it tells you the variables is the wrong type of class or something. The second thing you can do is to Google the error, and usually people will have some solution and will tell you what you did wrong. The third thing that you could do is use help to see if the arguments you use are in the correct format, and if everything is correctly. And the help, as we saw yesterday, this help command is simply a question mark and the name of the function that you are trying to run. And the fourth thing that you can do is simply use the package manual. And so usually when you have a package manual, like this one, for instance, this is the one that the package that we are using. Usually they will come with some toy data, some examples using toy data that they have. And so when they use these toy data examples, you can simply copy this and put it in your own code. And so you can play with it, substitute, replace things to maybe try to mimic whatever you had so that you can understand. First of all, you are going to have a better understanding of how it works, and you are going to be able to identify more often, and I have used this a lot, more often than not, you are going to be able to identify what you did wrong because it was something that the documentation didn't tell you, but the package is doing. Like for instance, the other day I had an error that it was because it needed some part of the function needed to be in a very specific format. And by playing with this and like using, instead of 3, putting a character or something like that, I could find out what I was doing wrong that I could not find in Googling or in any other way. So this is a very useful tool that you can apply for when you have problems and you can have to troubleshoot. All right. For more information about the things that I did today, you can also type like help, network, run this little line of code, or attribute methods for how you add attributes. I went a little bit quickly through this part. Maybe we could go back and try to work on it again. But these are very useful information that you can find on how you can, different things that you can do, different functions that could be useful, and more information in general to understand the process. All right, and that's it. Do you have any questions? Something that I can help with? It was a lot.
It prints out a bunch of red text, and you think like, oh, error, red, bad, warning, and it's not. It's fine. It just does that because it's telling you, in some sense, like for StatNet, it tells you who to give credit to if you're citing StatNet, or it tells you it's masking other functions from from other packages. So a lot of people have said, oh, it didn't work because there's red text and it's doing fine.
Yeah.
Can you just speak briefly to sort, the importance of having data sorted properly, like with the B operator and things like that?
Yeah. And I have that. So for sorting data sets, you usually use the arrange function, and this is going to give you so for instance, here, instead of being like this, a random number, 108 or 100 something, is the 2, that is the first node that has an edge. So the way I did this is by using this arrange function. And you tell it arrange, and you give it arrange by what, like by which column you want it to arrange. And so I told it, oh, I want it to be arranged by sender, and it's going to arrange it that way. The functions in StatNet is important that you do this, that you have your edge list ordered. I'm not entirely sure. I have never experienced that because I have always had it ordered, but I heard that sometimes you can have trouble breathing in creating the network object when you don't have it arranged.
Let me give you a more concrete, because it's actually the data you're going to look at tomorrow. You can say you have an ID, and then I filtered by community 7, and say person 2 isn't in community 7. So now the ID list goes 1, 3, 4, 5, blah, 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 right? And then say there's a few other gaps. The issue is that now StatNet's going to be like, wait, what? There's no 2. And then when you're trying to merge attributes, StatNet is using the order. And this is even more problematic when you are outputting things. Say you do some data management R, and then you want to use Pike, for instance. That will show up in a little bit. Pike is completely order dependent. So if your numeric ID is not perfectly sequential, and you don't have an ID variable that links to your attributes that is sequential, you're going to basically be misattributing attributes, and frankly, StatNet may not even run. So that's the ordering issue. It's when if you have a perfectly ordered data set, then life is great. But oftentimes that's not the case. And in fact, when we go through the code yesterday and tomorrow, we make a new numeric ID that's completely sequential to avoid these problems. But that's the issue. One other thing I'd bring up that to reinforce what Cristina was doing is on making, when Cristina said the isolates are super important and she visualized that network. That's true. And in addition, you say you have a survey and someone lists 5 friends, and let's say you're in ad health or in some school context. And one of the people actually said, no, I don't want to be part of the survey. So they're not an ID number in your ID list, in your column. But friends were nominating them. Betsy's great. And Betsy actually has a high degree centrality. But Betsy, for privacy reasons, was like, I just don't want anything to do with that health. Right? So it's important when you're that you think about making a comprehensive node list, not just dependent on the ID column, but you take the ID column, you stack it with the edges, and then also when you do that you don't lose the isolates. So there's sort of 3 considerations there. Because otherwise, and the last sort of thought about that is with attributes. So Maria Cristina was like, you got to really focus on the characteristics of the attributes. Well, you also have to think about the coverage of the attributes. So say you have alters that are identified by IDs, but you don't have maybe you can infer gender by their first name or something, but you don't have characteristics about them that you have about the IDs, race or socioeconomic status or things like that. So if your network analysis is really contingent on knowing something about the people you're talking about, then you have to think about, what am I going to do about this issue? Or is that a limitation in my analysis? And these are sort of questions that will come up again and again as we move across the week. But I just wanted to really reinforce thinking about the descriptives and thinking about the coverage of descriptives across the nodes that we actually have.
this is where you're all going to spend your time. I mean, this is where you're going to spend a lot of time the next few days. We're going to show you some cool tricks on nice, clean, workable data where everything works. And you're going to go home with your own data, and you're going to beat your head on the wall for hours trying to figure out why there's no grade homology in your school, and it's going to come out because you were missing a sort value and you didn't get things collected right, and you're giving people the wrong grade or some such. So it really is the kind of thing that you want to just take the time, and I think Maria did an absolutely fantastic job, to lay out a plan and really look at your data and pay attention and really make sure that when apples are linked to apples, they're really linked to apples, and that's the kind of thing that it's gonna be really painful. If you ever want to know why this matters, one of the most embarrassing comments and replies ever to appear in the ASR was when Tasoki Kanazawa said, "No, I wanted to keep the -9s in my data set because I felt they were informative." Right? You never want to be in a position where you're trying to defend having made a mistake as egregious as that. Right? So you can avoid that if you follow the kind of steps that Maria laid out, where you're really careful, you're watching your data, you're making sense of what's there, and you're doing this work. And this is one of the nice things about having teams where you can work with each other and say, look, this isn't working for me, and someone else can look at it with fresh eyes and see what's there. Because the strategy is clear, the actual process of going through it is just a lot of hard grunt work, and you just got to do it. So thank you very much. Other questions or comments? Lean on each other. We're going to shift gears a little bit and get ready for lunch. And the lunch talk today is Ashton Berger talking about RDS. So thank you, Maria.
Yeah.